look at this model. For these determinate multi-span beams, thinking about two questions. One is, why this type of structure are commonly used in road bridges? The second question is, how long the extend length here and here of an overhanging part is reasonable. Look at this picture. It shows us the Nanjing Yangtze River Bridge. The main bridge has 10 spans. One is simply supported beam. Its span is 128 meters. The other 3 spans are continuous beams. Each span is 160 meters. So actually, this bridge contains 2 models. Look at these 3 models. The first one is 2 neighboring simply supported beam. This model is a determinate multi-span beam. This is a continuous beams. They have different constraints. Actually, different constraints will affect the internal forces and the reactions of the beams. Today we discuss the comparison of these 3 types of beams. Supposing that if these 3 types of beams have same spans and under the action of same external loads. Look at this first one. This is 2 neighboring simply supported beam under the action of uniformly distributed load Q. We could draw the bending moment diagrams. Each part is a parabola, and the ordinate here is QL squared over 8. That's easy to understand. For this continuous beam, now we don't know how to solve this kind of indeterminate beam. Let me give you the bending moment diagrams. Like this. Actually, we could solve MB is equal to QL squared over 8. Then using superposition method segment by segment, we could connect MA and MB by a dashed line and superimpose such a parabola. And we could construct the bending moment diagram for the BC part by using the same method. Actually, we could solve the values of the middle section of MAB part and MBC part. They are all smaller than QL squared over 8. Now look at these determinate multi-span beams under the action of uniformly distributed load Q. Now we want to determine the location of hinge D to guarantee the maximum positive bending moment equal to the -1. That means we want to solve the value x to make the maximum positive bending moment equal to the -1. According to geometric construction, AD part is a subsidiary portion, so we could analyze AD part firstly. AD part can be considered as such a simply supported beam. Under the action of uniformly distributed load Q, we could solve reaction RD, and the bending moment diagram is such a parabola. The value for the middle part of AD, M is equal to Q times L minus X squared over 8. According to sigma MA is equal to 0, we could solve RD is equal to Q times L minus X over 2 upward. Then for the main portion, DBC, there will be a reaction at hinge D. RD is downward, and the DBC part is under the action of uniformly distributed load Q. Then we could solve MB is equal to half of QX squared plus RD times X. RD is equal to Q times L minus X over 2 and times X. For the section B, according to the direction of RD and Q, we could determine that upper side in tension, so that's the negative value of bending moment. Then according to the condition, we want to guarantee maximum positive bending moment equal to the -1. That means we want to let this value Q times L minus X squared over 8 is equal to the -1 MB. According to this equation, we could solve the value of X is equal to 0.172 L. And then, according to the value of X, we could obtain the value of MB, that's 0.086 QL squared. That means when X is equal to 0.172 L, we could guarantee the maximum positive bending moment equal to the -1. At this condition, we could draw the bending moment diagram. Here, the maximum value of M is equal to 0.086 QL squared. Then let's compare the 3 different types of beams under the action of same external load Q. For this determinate multi-span beam, the maximum bending moment is 0.086 QL squared. It's smaller than the 2 neighboring simply supported beam, which is 0.125 QL squared. But the support reaction of the middle support here, that's 1.17 QL, is greater than the 2 neighboring simply supported beam here, that's QL. For the continuous beams, the bending moment at section B here is QL squared over 8. It's larger than the maximum value of M for determinate multi-span beam. So, the maximum bending moment in each span of the determinate 2-span beam is the smallest. And according to the bending moment diagrams, we find that the bending moment distribution of the determinate multi-span beam is more reasonable, but the support reactions in the middle is greater. It's more complicated in construction for the determinate multi-span beam because it has hinges in the system. That's all for today. Thank you for your attention.